Greetings everyone. Today we're going to explore solving by square roots. When we think about solving a linear equation, meaning isolating the main function, which is x, we do PEMDAS backwards. We isolate the variable. When we get to our solution, we have one solution because technically the degree is 1. So now that we're going to have a squared, that means I should have 2 solutions in the end. And when we consider solving using PEMDAS backwards, we're still going to add or subtract first. We're still going to multiply or divide second. But now we're going to undo the exponent. So instead of squaring, we're going to square root. So in that process of square rooting, we're going to create 2 solutions. All right, so let's take a look. First and foremost, if you can factor, you should always factor, especially with simple ones like this. We've got 3 terms. We can see that 6 can get me to a 1. We're going to have a negative positive, and as we've explored previously, each factor becomes its own little equation, and getting those 2 solutions is really clear. Now, to solve by square roots, we're going to isolate. We're going to kick to the other side. But in this moment of square rooting, when we square root, we need to account for the positive and the negative value of that square root. Meaning, think about it. 3 squared is 9, but negative 3 squared is also 9. So we have to account for the positive and the negative. A helpful list would be our perfect squares list. You don't need to write this down every time, you don't need it in your notes, but sometimes just having it handy allows for simplifying our radicals to be a little bit faster process. All right, in your notes sheet we do have these examples, but they'd be quick to jot down if you don't have the foldable. We want to isolate the squared value. So again, PEMDAS backwards. Undo any addition or subtraction. Undo any multiplication or division, right? All of this is algebra 1 level work. Now at this point, this is where we're amping it up to algebra 2. Instead of squaring, we're going to square root. So those go away. We need to account for the positive and the negative value. And then we need to apply our knowledge from previous. A negative under the radical becomes imaginary. And then we're going to backtrack to geometry. What does the square root of 12 break down into? Meaning, what's a perfect square that fits into 12? 4. The square root of 4 is 2. We have an imaginary, and we have square root of 3, which does not reduce. Another way you might see these answers written is 2i radical 3 and negative 2i radical 3. But it's just easier to throw the plus or minus out front. Let's try another one and see what happens. Undo any addition or subtraction. Undo any multiplication or division. And in this case, I can simplify my fraction a little, but we don't want decimals, we want improper fractions. And my last step, instead of squaring, I'm going to square root, right? Okay, so let's take a look at this. I have plus or minus the square root of 7 halves. Ooh, let's go back to geometry. When you guys had special right triangles, you did this a lot. You'd have a radical 2 in the bottom. You can't divide by anything irrational. You can't leave it that way. We can't have zeros in the denominator. We can't have pi in the denominator. We can't have imaginaries in the denominator. And now we're adding on, we can't have radicals in the denominator. So we're going to do what's called rationalize the denominator. Okay, meaning we're going to multiply the top and the bottom by the bottom. So let me break this down off to the side. I currently have, I'm going to split it up, square root of 7 times square root of 2. or over square root of 2. We're going to multiply the top and bottom by square root of 2. That gets me to square root of 14. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. When you multiply a radicand by itself, you arrive at that integer. So my final solution, I've got plus or minus square root of 14 over 2. All right, this one's going to change things a little bit because I have an expression. So we start off the same way. I'm going to add 1 and divide by 3. If you want to skip over some of this work because you know where those 2 steps will get you, that's fine. Or if you just know, hey, I'm going to divide by 3 and just don't show it, that's fine. That's Algebra 1 level. Now at this point, I want to see more work. Instead of squaring, we're going to square root. I arrive at x minus 2 equals positive and negative square root of 40 over square root of 3. Okay, I need to rationalize the denominator. I'm going to take top and bottom by square root of 3. That gets me to square root of 120 over 3. I'm going to keep going to the right here. Square root of 120 has a perfect square. It ends up being 4 times 30. Well, square root of 4 is 2. Square root of 30 stays square root of 30. And 3 is just carried over as my denominator. So let me bring this back. The left side we didn't touch. The right side's a positive and negative. And we have 2 square root of 30 over 3. Here's where things get interesting. Here's where you need to slow down a little bit. I'm going to add 2, right? I got one more step. But when you add 2, you should add 2 to the front of that expression. 2 plus or minus 2 square root of 30 over 3. Kind of like complex numbers. You want to keep the clean part out front, right? And then follow with the messy piece. Now, I threw in this extra example. You don't have it in your notes, but I just wanted to show you something else that can happen, or that's going to happen, and clarify that. Okay, so I'm going to just add 20 to the other side, right? Following the same steps. I'm going to square root both sides. So I've got an x minus 2, a plus or minus. Now, this is a perfect square. It's going to be just 6. So at this point, follow the same steps as the previous. I'm going to add 2, but I keep saying add 2 to the front, right? All right, x falls down. I've got 2 plus or minus 6. We can calculate. That's not messy. What is 2 plus 6? 8. What's 2 minus 6? Negative 4. See how that creates 2 completely different solutions. We're also going to be working on some word problems. Now in these problems, you will typically be given the formula. So your goal is you're going to have to fill in the variables you know. So let's read through. When an object is dropped, its height in feet can be modeled as this equation. H sub O is the initial height. T is time in seconds. All right. If you drop a baseball off the roof of a 200-foot building, 200 foot, that's my original height. That's my H sub 0. So I'm going to fill that in first. So 200. We're going to keep the plus sign, got the negative 16, got the equals. And then if we take a look, T is time. Do I know the time that it takes? Well, no, that's the question. How many seconds? I don't know what T is. But what about that left side, right? I've got to take care of this piece over here. What's H of T? So what that means is, what's the height at the end? Well, it's saying when, or how long, excuse me, does it take to hit the ground? What's the height when it hits the ground? 0. So you weren't given that number. You need to assume that number. I might ask you, what is the time when the height reaches the second floor? at 500 feet. You know, you're going to have to be given some information. This information was just given in words, okay? All right, let's do a little bit of solving here. I'm going to subtract 200. And you guys, the nice thing about these word problems is, in the end, they need to make sense, right? I'm going to divide both sides by -16. All right, t squared equals a negative divided by a negative is a positive. I'm going to cut in half. That'd be 100 over 8. I'm going to cut in half again, 50/4. You know what? I'm going to leave it like that. I could keep going, you guys. I could. But I'm going to leave it as 50/4 because watch what happens. When I square root, t equals square root of 50 over square root of 4. Square root of 4 is 2. That's handy. Let's break that down. 50 is 25 and 2. So I'm going to have 5 square root of 2 over 2. Now hold up a second. Is that how we talk about time? Would you be like, yeah, it took 5 radical 2 over 2 seconds? No, right? So what I need you to practice right now is in your calculator, plug that in. I'm going to see if you are using parentheses correctly, if it makes sense. So as a final answer, you should get approximately, you will have to round, so we want to use the approximation symbol. And actually I'm going to truncate. I'm going to say 3.5 seconds. Right? 3 just doesn't seem accurate enough. A couple decimals seems a little much. I'm just going to say 3.5. If you're not getting that on your calculator, please let me know so we can visit. All right, as always, check out Google Classroom to see what the task is for today. Let me know if you have any questions. Make sure to check out the Saber Center if you need some extra help. And until next time, have a good one.